Okay, we have know how to find the equation of a circle given the radius as well as the center, or the other way around, given the equation of a circle, how to actually find its radius as well as center. But now we're going to go in the word problem, and let me highlight to you, as mentioned previously, this is the most important word problem because it actually involves concept that we have done previously in Sec 3 as well. Okay, I will need you to refer to practice now 5 on page 192. This is a star question because the concept is very important. Alright, the question we're dealing with is question 1. Okay? Find the equation of the circle which passes through the point A and B and has its center lying on the line. So I'm going to draw a simple sketch so we can visualize the question better. So what they are saying is there are a point A, the coordinate is 2, 6. That's another point B, minus 2, negative 2. And the center lies on the line called y is equal to x plus 1. So this is the center, and it lies on this straight line called y is equal to x plus 1. Okay, as mentioned previously, there are two very important concepts inside here. The first concept is, so long there are 2 points lying on the circumference of the circle, I can draw a triangle. And you notice, point A to the center and point B to the center are both the radius. So it means that this is a isosceles triangle. And the amazing thing is, whenever there is an isosceles triangle, we can draw a perpendicular bisector that passes through the midpoint of A and B. This perpendicular bisector will pass through the midpoint of A and B, and I'll label this as N. In other words, the perpendicular bisector also passes through the center of the circle. The line given in the question also passes through the center of the circle. With the intersection of the red line, which is the perpendicular bisector, as well as the blue line, which is the line given in the question, we can solve for simultaneous equation, the concept learned in Sec 3, the very first chapter, and we are done for this chapter. Okay? So I'm going to do this part by part. The most important thing now is to find the red line, which is the perpendicular bisector of AB. In order for us to do that, we need to find the gradient of AB first. Okay? Finding the gradient of AB, 6 minus negative 2, 2 minus negative 2. This is the gradient of AB. But if I want the gradient of this perpendicular bisector of AB, to make things easy, let me call this line 1. The gradient of L1 multiplied by the gradient of AB will be equal to negative 1 because these two lines are perpendicular to each other. Alright, so the product of the gradient is equal to negative 1. In other words, the gradient of this straight line is negative half. But we need to use a point to substitute before we can find the equation of this line. And what is the point we need to find? Will be the midpoint of AB. Which is the average of the x coordinate and the average of the y coordinate. Then we are ready to find the equation of the perpendicular bisector. Since the gradient is negative half, we use this point to substitute inside here. In other words, the equation of the line L1 is found. Okay, this is the equation of the line L1. Okay, making use of the concept of the isosceles triangle, we are able to find the perpendicular bisector. Finding the equation of the perpendicular bisector, we will move on to the next part, which is the use of simultaneous equation. This is a very important concept. As you can see, the perpendicular bisector L1 passes through the center. The given line in blue also passes through the center. So with the use of simultaneous equation, this is equation 1, this is equation 2, I'm going to solve for this unknown center itself. So this will be the center of the circle itself. Now comes the thing. Center has been found. How do we find the radius? Straightforward. The center to this point B or the center to this point A must be the radius of the circle itself. Let us use a convenient point then. So radius, okay, using the formula for the distance between 2 points. Okay, I'm going to use my calculator and work out the value. Okay, this will be the radius of the circle because I didn't simplify to the form where I put decimal because this is not our final answer. I would like to be exact first. So after that, okay, I can use back on the standard form to find the equation of the circle since the center as well as the radius is given. So with that, x minus 2/3 bracket square plus y minus 1 and 2/3 bracket square is equal to the radius square. Okay, after that you will have to expand everything and simplify it equated to 0 before you get the equation of the circle. I'll leave that to you. Okay, so basically let us recap. The use of isosceles triangle to find the perpendicular bisector, the use of simultaneous equation for intersection of the bisector as well as the given line at the center to find the center itself. Okay, with that I'm done with this work example. Thank you.